Welcome, everyone. We are live here in the Platformers community. If you're watching in YouTube or LinkedIn, please comment, like, and share to everyone that is not watching us. And it has been 2 weeks since having not talked about platform engineering. We have not done a live stream, so I'm pretty excited to come back here. And we have a special guest today, Greg Haynes from Siemens. Greg, welcome to the platform community live stream.
Thanks, Carlos. Yeah, really excited to be here, and also really excited to talk about our topic today. Ownership models and platforms.
Yeah, we have been having great guests. We had Lynn talking about meeting K agent, and we also had Bob talking about AI's roles. And then today's topic will be talking about platform ownership model and also your role, your new role, because you joined recently, right? This year you joined a corporation, Siemens, and you're going to talk us about your journey about how Siemens is doing platform engineering and how the ownership model works at the scale of Siemens, and then what Siemens does for it. So you want to give us an introduction, Greg, before we start with some from diagrams on what's your role, or maybe people that don't know you, you've been in the Kubernetes community for a while doing open source, right?
Yep. Yeah, happy to. So as you mentioned, I joined Siemens not too long ago. It's been about 8 months now. But I came over here to help their effort to build up an internal developer platform for a very, very large company. Siemens is an extremely large company. We have a lot of engineers. We have more hardware engineers than anything else, but we also have a lot of software engineers. And so I came over here to take on this pretty exciting challenge of, how do you build a developer platform at the scale of, tens of thousands of engineers, which is a bit unique of an opportunity. And it's been wonderful. It's been a great opportunity for me. Before
And
that, though, sorry, go ahead.
yeah, go ahead.
Yeah, so before that, I was at Autodesk for a while, and as you mentioned, I've spent most of my career doing open source software development. So I spent a lot of time working on different Kubernetes-related open source projects, Knative and some other projects. And before that, spent a while working on OpenStack as well. So I've been in sort of this cloud developer platform space before it was called that. It's going on a couple decades now.
Yeah, it's impressive, right? That we used to work on OpenStack when we were doing what's called infrastructure, right? Layer, the different layers, the PaaS, the AI, AIS, all those layers with OpenStack, and there's companies using it today. But it's impressive how Kubernetes have the CNCF, right? 10 years already. Like 10 years was Kubernetes last year birthday, and then this summer is CNCF, because CNCF was founded a year after Kubernetes was announced. It's 10 years. I think that's longer than OpenStack and the other frameworks out there for running compute storage and network, right? These are softwares that need these resources.
Yeah, and yeah, you're totally right. It's crazy. It's been 10 years. It's hard to think about. And it's also, the scope of it has changed so much over those 10 years. We started out thinking about running containers, and now what that CNCF ecosystem has become something very different than what I imagine pretty much anyone imagined at the beginning.
Yeah, like Docker and container, like that's why I said compute. Like 10 years of compute, and like, well, it started with compute, just running a container, orchestrating a container. Where do I put this container, and which VM is there's space available, to now these standards about the network CNI, and then we have CSI for storage, and we have actually the standard for the Kubernetes image, right? It's become a transport packaging mechanism, not just for the files for the operating system and apps, but so like other aspects like YAML files and Helm charts and anything that you can package in a container image that then now you can transport and make available everywhere. So it's been a journey, and with so much standards, right, comes with ownership. And I think that's the topic of today. Like when you have standards and you have tools that are being used by everyone, there's so much complexity with so many aspects of it that no single team can own everything, right, in our large corporation. So let's see some of the slides that you shared today with us, I'll put it up, and we'll talk a little bit about that platform ownership that we want to discuss today. See if that's showing.
Yeah, I'm really glad you made that connection about how much it's changed over the years and how that's added some complexity and challenges around ownership here. Right? 'Cause so you think back when we're just talking about OpenStack. Do you want to show that first diagram I have in here? That'd be a good
Yeah.
start. If you think way back, we're the separation was a little bit easier between sort of the platform providers, or in this case, what here are operators and the developers. And I know some feedback I would get on this is like, well, look, are those necessarily different teams or people? Maybe they're the same team. And so, like, I kind of want to sidestep that part of the discussion. Just assume that there's different problems needing to be solved here by either the same group of people or two different groups of people. And when you think about old cloud infrastructure days, we were providing compute infrastructure to these software development teams, and the ownership or the interface there is fairly clean. I keep the infrastructure running. You give me your application to run on the infrastructure. And in a way, like, that's the most simple model. That's kind of what I'm trying to show here, is that where a lot of people start today, in where people were decades ago, there was infrastructure that teams need to leverage, but app teams by and large are responsible for everything on top of that infrastructure. But where we're heading with platform engineering is really those green and blue boxes I have in this diagram inside these applications, finding ways to remove that common either toil or effort needed in order to build their applications on top of this infrastructure.
I think that's the transition, right, to the next one.
Yeah, exactly. So this is sort of the ideal here. Is like we're finding ways to take those blue and green boxes, those common things that were across all these applications, and pull them out into places that can be what we're calling the platform. But
And it's
essentially,
the methodology of being dry, right? When you have these teams that are building these applications, and large organizations, you have different teams building different aspects of services that and sometimes they integrate or not, but they are like then using their time not effectively, right? If they can be dry, right, to the point that why do I need to repeat myself when I move to a different team, right? Me as a developer, I work on this team for 6 months, and then next month I got moved to the next one, and then you notice, like, you guys are doing the same thing that we were doing over there, like talking about, like, how do we solve the release, how do we build, how do we sign, how do we put the software, how do we monitor. Like, I just did that 6 months ago in the last team, and it's the same company. Like, what's going on? So all that effort, right, and amount of time, like, it gets compounded, right? That amount of time, can we just remove it out of the app team, out of that team that is just concentrating on like the business logic?
Yep. Yeah, and I love what you said there about how that's compounded, right? Like, we talk about things like tech debt or like the toil, but yeah, it's a really important point you made there. You kind of jumped straight into one of the more advanced but really important topics, is that it's not just removing the effort up front. Like, oh yeah, sure, I could take some service that or some automation out of the application, the need for an application team to develop, but creating that consistency across applications has compounding effects, where now those engineers can collaborate across teams, they can communicate our problems, and they can also, collaborate to come up with a better solution than what any of them could do independently. So it's not just that direct benefit of removing that engineering cost or toil. There's like also all these compounding effects that we see when we start to do this work.
Yeah, and then when I was doing in different companies that I work with, and that's why I give that vivid example, because in some of the organizations that I work with, there was always silos, so nobody knew what the other team just did 6 months ago or last year, until the organization started by moving people around, because people had expertise on networking, or some other folks had expertise in operating systems. Like, there was such thing called as a Microsoft shop. I remember, like, this is like dating myself, 20 years ago, we used to talk about, like, this is the Linux shop or a Microsoft shop, and you have people with different skills, and then you have people with Fire Channel skills, and then the application came along where, like, you needed to move people around because they build a service, they build an app, and they move to the next project, to the next project that it's actually going to grow the business, right? They're always looking for what's the next project that companies are going to bet that they're going to like grow the business. So you have to move some of the key people on that team to accelerate that, while others maintain the apps, and then they take it to a point that they don't waste a lot of time maintaining it. Like the app is robust, is done, and it's just currency. But when
Yeah.
you move people around, then people start asking questions like, why are we doing this like again? Like this other team used to do it like that. Um, and there's no central organization to ask like, what's the best way to do software? What's the best way to secure the software?
Yep. And so one thing that that keeps coming up, and it's a line that I've used a lot to try and evangelize what we are doing, is this balance between, we call it the balancing standardization and leverage, right? So if you look at this diagram here, one of the challenge is that, now all these apps, they're depending on one thing. That means they have that usually have had to perform some amount of standardization. You can't, if every app still depends on its own independent version in this platform services, you haven't actually gained the benefit. Like the real benefit is creating that standardization so you can centralize work and also create consistency. And then when you do that, you create that standardization, you get that leverage where you can say, you know what, something changed. We need to go adapt. We need to enter some new market. We need to have some new compliance regime, something like that. You can implement it once because you've standardized. But that's the difficulty, is that all these applications, all the different teams have to perform that standardization at some point, and that's very difficult. And then,
So at Siemens, like tell us a little bit about Siemens scope, right? You have developers, but you have different type of applications, right? Siemens, what I understand, is a transportation and more than that, right?
yeah, exactly. The scale matters here a lot, and that's what's so awesome about working at Siemens, is that we're talking tens of thousands of engineers, right? And so trying to standardize that number of development teams is extremely difficult. It's not only understanding the scope of the problem and the needs of the developers, but also getting their buy-in and getting the feedback, or even understanding how many developers exist within a domain. So kind of what I think you were getting at is, we've got to come up with ways to think about our developers internally. And one of the main things tools we use is we personify them. We've done this a lot as a way to just think like, hey, how can we break down the customer base that we're serving? So there's a large part of Siemens that does embedded software development. And these are, there's embedded software that goes into the trains that you ride in. There's embedded software for, industrial equipment. There's all sorts of embedded software we make. And that's one, there's a lot of commonalities for how those engineers work within the SDLC. For example, they're not as interested in cloud delivery pipelines, but they are really interested in validation, right? And we can go on different extremes as well. We have a class of developers that make SaaS software. We make large-scale desktop software, we make large-scale SaaS software, and those different personas, they have different requirements. They have different number of engineers within the company, and they also have, when we look at the things we can put into either automations or these platform services, they'll have different impacts to those different personas. So that's kind of something we focus on a lot.
And you said something and you didn't notice. You call them customers, and these are like developers in your same company. These are employees. So as a platform team, right, you are part of an organization that is trying to create a centralized platform of services, right, to minimize that extra effort and time. Like sometimes not cost, it's just time. Like you have to deliver apps, and this extra effort that every app needs to do, it delays projects. But also cost. So when you talk to them, these users, which are your employees, are your co-workers, you call them customers, are large organizations, and I can imagine that different areas have a budget for like IT to like hire developers, buy desktops, buy their part of their cloud infrastructure, or pay for part of the on-premise data center. You are like asking them to not get more budget, or have their budget reduced next year, because that small amount of that budget for every organization is going to be contributed to this central platform, with the hope, right, that this platform centralization provides what they need at the time they need it, right? They don't want to be like, well, we're going to ship on July. Now we depend on this other team. It's not in our control. We don't have the budget. We gave the budget to them. Now they will depend on them to have CI/CDs up and running, to have the right VMs up running, or maybe having Kubernetes, like all these things to run our apps. And you're going to be asking every individual line of business that. Is that the use case, the case for Siemens? I've seen in all the companies, but I don't know if Siemens work like that.
Um, I imagine the way it works in Siemens is probably not the same way it works everywhere else, but there's probably some similarities. I think yeah, it's a really good point. You have several really good points. Like you got to understand how are you going to fit within the budgeting structure and the financial structure of your company. You're completely right. That's something we spend a lot of time working on. But one thing, what I would like to actually focus on a little bit more, especially with me as like an engineering and technical background, is there's some things you have to do no matter where you are that we have to do at Siemens. And like one of the most important things is you can't go to these different organizations and these development teams, regardless of the organizational or the budgeting structure, and essentially say, you know what, I'm here to replace you, or like I'm going to go make something without you. That won't work on several dimensions. You know, one, you're going to alienate the very people you need to work with. Two, you know, that's one of the least effective ways to build any product, whether it's an internal or an external product. The most effective way is to work closely with your customers, not, you know, alienate them and then build something independent of them. So no matter where you are, like the most critical thing is you've got to go out to those teams who are already doing this type of work and bring them in. Like that's the most basic step you have to do. So that looks like, you know, okay, hey, you've already got this thing. And remember earlier on, I talked about how one of the biggest challenges we have is just understanding what exists and having the data. And that's what a lot of our time is spent. It's like, hey, what teams are already doing this? Let's go out and understand what they're doing and how they're doing it. Let's go have them help us design what they think this should look like for the whole company. And so that's one of my favorite tactics is to, you know, pick the existing winner, don't replace it, and let them grow. Let them help you build the platform.
I see. So that's a lesson learned, right? That I think you got from other looking into other organizations. Like you're part of the Canoe project, where other organizations are sharing their stories on how they have done it in the past, what works, what doesn't work, and you're like highlighting one lesson learned for folks watching the live stream that they can get out is reach out to the customers as early as possible. Right? Do not try to build a platform or a service or an IT centralized service and spend all the time creating something that works for everyone, like a single interface or this Nirvana CI/CD pipeline or this golden path, and spend time doing that, and then going saying, "Hey, use the thing that I built," and they will come. Like you're telling them as early as possible, reach out to those personas because those personas could be have different requirements or the way they do things, like understand how they would do like the embedded systems, right? You have embedded system or hardware people or developers desktop, and then you have other people building SaaS. The way they work, the way they expect to work is differently. So reaching out early is kind of like the lesson learned. Is that what
Reaching
you
out
mean?
early, and also like you don't discount their experience is the other huge lesson learned. You know, a lot, even if I go talk to some of these embedded teams, and I've worked in cloud developer platform space for a long time, but then when I go see a lot of the like validation processes that these embedded teams have developed, I'm like, wow, this is well beyond anything I've seen in my recent memory. We should use that. I don't. Why would I want to replace that? I want to pull them in and like let them share their expertise and build it into the platform so the whole company can benefit from it, which is a very different message, right? That's I'm not here to replace you. I'm here to help you do your job even more effectively and at a larger scale.
So you are actually leveraging the knowledge and the background of that engineering effort. I mean, in Siemens is a uh, company that has a lot of hardware locations, right? So they're building devices and software that need to sustain remote location with low connectivity, sustain weather events. Electricity may go out and come back, right? You have to do firmware updates across thousands of endpoints and redundancy, right? That that is not thrown away, right? That's something that can be leveraged in cloud native.
Yeah, absolutely. And there's a lot of practices that that are built up from that hardware industry that are awesome. They are frankly probably ahead of where a lot of the software development practices are. This is that's not a the development work that those teams have been done has been going on for many decades. And there's all that experience to gain. However, then there's also a lot of changes that are coming in now. Like, as when you talk about transitioning some factory floor software to making SaaS software, that's what kind of the trick is. So there's a lot of overlap there, and ideally you're picking the best of both about all those different use cases. But in the SaaS world, we've kind of switched to this model where we're going to make the hardware intentionally, or not even the hardware, the infrastructure intentionally even less reliable, and we're going to rely more on scale and redundancy at the application layer. That's just a sort of general pattern of doing this cloud computing software, which is very different than how a lot of older software or hardware tends to work. You tend to want to build redundancy into the infrastructure below
The
so
hardware.
it become more reliable. So, but ideally what you're doing is you're looking at that and saying, like, look, this is the strength over here, this is the strength over here. And then you can go back to these personas and say, like, well, this persona needs these strengths. And so this is what we're going to try and provide you with.
Let me see. So what are the aspects here that we have in terms of, I see authentication and databases for these applications?
Yeah, so I want to come back to ownership models in this diagram and talk about kind of two examples that I think are sort of extremes here. Like, part of the problem, the reason I like talking about ownership models so much is it's something I've seen be a challenge every time I've worked in this space. Like, every organization struggles with this. And it's also something I'm not sure there's a great answer to. There's a lot of different answers and there's a lot of different perspectives. So it's a good discussion topic of, like, hey, here's my experience, here's what I've seen, here's what the challenges are. Frankly, there's not like a one clear answer for all these cases. And so here's some examples. Is say one thing that these platform teams often do is they got to build some authentication system into the platform layer. That's a very common and core use case. All these applications need to have auth. You need to be able to integrate with the auth systems. You don't want your users having in-auth system, or experiencing in-auth systems. So it's a really common thing to pull in. Well, so the test I always like to use for ownership is, who's on call when the thing stops working, who gets paged, who has to go fix it. And if your auth system starts 500ing, I would expect the platform team, which owns that auth system, to be the one who gets paged. That's something where the ownership really gets pulled into the platform. However, if you're using the auth system in a certain way where it's misconfigured as an application, or maybe your usage or your configuration of it, so maybe your keys are not being properly configured for this auth system, you'd expect that to be on the app team. So there's actually already a split ownership there. However, this one, for the most part, that service gets pulled into the platform layer for ownership. Now, the other example here is an example is a database. So for those of us who've worked with relational databases, and especially for building large applications, one thing you kind of learn is that application teams have to be responsible for doing the data modeling, the query optimization, the schema management, all those types of things. You can't say, hey, or you can, but it's usually not very effective to say, like, the platform team will own all of this. Even for like even without functional reasons, like there's reasons you don't want to split that responsibility, because you want to create the right incentives for your app teams to model their data properly and optimize the queries. However, there's some benefit you need to still get where you want to create consistency about how your databases are managed. You want to be able to do compliance without having to treat every database as its own unique item. So this is one of the harder ones I always run into. Is like, well, yeah, you got to have automation and consistency created by the platform for databases. However, you really want app teams to be on call if there's like a scale, or like if there's a usage problem that's causing this database to not work, because they need to own that data and usage at the end of the day.
Yeah, this comes a lot on projects that we have working together, right? On like making it super easy for the app team to create a database. But databases are a resource, and you're talking about ownership. In my world, we call it like shared responsibility model for the cloud provider that I work with, where Yeah, you can click a button. I'll give you a server with CPU, an operating system, and it's running Postgres. That's it. Like,
Yep.
and I'll give you options to back it up. But the schema you mentioned, like the schema of the application, and switching from one schema to another, or the tables, loading it up, configuring users, that's up to you. You are the one using that database. The application team, right? The application team will be like the one, like, setting up the keys and optimizing the queries and doing testing on which query is taking the longest. But the platform team, the infrastructure team, is in charge of like making sure that it's right size, for example, right? It's a right amount of memory and CPU, so we don't go over budget and still the application works. We'll handle databases to handle, like, I guess, like Siemens has different regulations of like keeping that data secure and also backup for X amount of time, because they have to meet certain contracts and regulations depending where they work, which country. And the app team is building the app that runs in in every country, so they're not sure. They should not be responsible or ownership of that, like, backup window or upgrading the version of the database. But you need a platform team that owns that. And then what about that operators to the cloud provider? I know you have on premise, but you have cloud provider. Like, that's another level of ownership? How do you manage that in Siemens, of like folks working with a cloud provider, but at the same time their consumers is the app developers?
Yeah, and so it's complicated. It's a difficult problem. Again, that's why I like talking about it. But so when we talk about that cloud provider case, notice here I say automations, right? This is for that database case, right? And it's kind of similar to what you were describing, where you'd expect we'll make something where the teams can click a button, right? It's your job to request the resources and provide information about how they need to be configured. But then when you talk about a cloud resource, the expectation is that the application team is generally responsible for using that resource effectively. Right? So the usage is on them. That being said, if there are cases where you can come up with a really clear interface where the platform team can own the resource, there's a benefit, but it always comes at a cost. So to me, that's why one of the challenging things here is like not all resources are created equal. Right? Like, so you think about the relational database case, one of the challenges there is that coupling between the application and the resource usage is fairly tight, right? Like, depending on how I use the resource, I might cause the resource to break. If I come with a bad schema or a bad query, I could cause the database to become overloaded. But there's other cases where the resource might be pretty resilient against how you use it, and you can come up with a really clear interface. Like, you think about these huge scale NoSQL database type schemas, like a spanner type of thing. You can kind of say, look, you're responsible for using the resource. I would expect this resource never to become overloaded within these bounds. If you fit within my quota and my parameters, I will manage the resource entirely. So that's one thing what we're doing. I'm always looking at with these cloud things, and which we have to do at Siemens as well. Is like, is this something that we should be own on the resource infrastructure level, or is this something where it's too tightly coupled to the application? Therefore, the application team needs to be more responsible.
But there should be sometimes, like you mentioned automation, so I'll give you one example. I've seen teams that when they work with like say the infrastructure is it could be on premise, it could be cloud, right? If it has APIs, it's a service provider, right? Providing the storage and providing databases, like, but I've seen teams that what they do is they put automation in place, and basically what they do is just a wrapper to every possible combination, every possible configuration to that infrastructure, and they just make it super easy for the application team, the developer, to, with automation, right, manage those APIs directly. So that sometimes it's just, you're just creating a transport layer. You're automating the ticket creation, but not guardrails of like, um, it should everybody create the same, like standardized on Postgres, standardized of like having different databases, instances, instead of sharing one database with a bunch of tables for production and non-production. Those are guardrails I think the platform team needs to own, or to be able to effectively like have the benefit of everybody doing the same thing, the correct thing.
Absolutely, yeah. And so that creating standardization or like creating a homogeneous use of certain types of resources is absolutely critical. I can't agree more. There's a couple different perspectives that we see at Siemens, and I've also seen other places where one of them is this, there's a whole set of things you really can't do without creating that standardization. You talk about compliance or like meeting certain non-functional requirements. Well, imagine if you're at a certain scale, like you've got tens or hundreds of thousands of these resources, and they're all different, and you want to say like now all of you need to meet some new, encryption requirement or some other like some type of standardization requirement. The cost is astronomical. Like you can't afford to do it most of the time. Even if you could at a technical level, the switching costs of going to all those teams and asking them to, hey, change your database to be like this, or like and even understanding when you would meet that requirement, it's an astronomical cost. So you can't even meet certain compliance requirements. So I've seen that be a driver at multiple places, including at Siemens. Is like we want to all meet some non-functional bar. We need to create standardization. That's a core driver to it.
So let's move on into this automation and standardization. Like, and one of the topics that we have talked in this, in LinkedIn and this YouTube channel is around using Kubernetes APIs to standardize. Standardize and make it super easy for like the developers that know Kubernetes, like myself, right? I know YAML. I can create a deployment. I can do kubectl apply. And boom, I have my app and URL and I can access it. I can do a config map, kubectl apply, I can get a config map. And this trend is happening where like, well, if Kubernetes is easy to get some configuration up and running, get a PVC volume and get storage, why I cannot model the infrastructure aspects like an S3 bucket, a Postgres database, a VPC, a Kubernetes cluster, right? Another type of database. So if you standardize on that, making it super easy for developers, what are your thoughts on that about using Kubernetes APIs or Kubernetes programming model, right? That comes embedded with some type of guardrails or namespaces or tenancy. How is Siemens looking into Kubernetes as the control plane?
Yeah, I'm glad you bring that up. As you know, I'm a huge proponent of that pattern of using the Kubernetes API as a control plane where it's appropriate. But there's a lot of cases where there's a lot of benefit to be had from doing that, and it's something that we're heavily invested in, and we're actually actively developing at the moment, using that technology as our sort of standard declarative and GitOps control plane. And the reason that I'm such a fan of it, and the impact that we're prioritizing it is kind of come back to this ownership thing. Ideally, even if, in addition to trying to pick the best ownership model, at least you got to make the ownership clear, right? That's almost just as important as picking the right ownership model, is that you've at least made what the intention is clear. And
yeah, it's like the on-call schedule, right?
yeah,
You
exactly.
who's on call? Like nobody wants to. You don't want to be in a team and say like, we don't know who's on call tonight. Like that should be the clear thing. Like who's on call. So who's the ownership for certain aspect of a service or resource, like a portion of it, right? It's difficult to delineate that. How do you do it in Siemens or thinking about it doing it?
Yeah, well, so it depends on the problem domain, but in this, you mentioned earlier about this automation area and how like sometimes these automations basically become like, okay, here's every variant out there. It's just a way to run different automation workflows depending on which variant you are. And in that space, this Kubernetes model, I think, forces some really good patterns for how you delineate that responsibility. You say, and it rather one anti-pattern I've seen a lot is these the way that those automations are delivered from the platform is essentially we'll provide you a pipeline engine, and any automation could go in there, but you're going to use our pipeline engine, and that's a very low level interface. That's like, okay, as long as you're using my executor, then you're on the platform. But it's still unclear who owns that automation for delivering a database or delivering a bucket or something. However, in this Kubernetes model, it really forces you to bring that abstraction up a level and say, like, look, here's the API to make a database in the standard way. Here's the information I need, and I will, everything that's not from that API, that's stuff that I own as the platform team. I own the implementation behind that API. You own the configuration and usage of that API. It doesn't solve everything, but it's just within that problem domain of delivering automations to provision resources or manage resources in general, and not just cloud resources. I mean, conceptually, any type of resource. It's a really good way to force some good habits of making that ownership and interface clear between the platform and the consumer.
And the thing is, if these applications run in Kubernetes, right, there's a little bit there's a chance that there's some synergy about like the metadata where this definition of the applications are located next to the dependencies that it needs, right? Because usually this infrastructure, because the app depends on authentication, it depends on storage, it depends on network, it depends on like meeting certain requirements like network policies, right?
Yep.
Be configured correctly, and having that as a together as a metadata that you put in Kubernetes, right, is a resource Kubernetes resource object model where you have specification, which is your desired state, and then status, where you have your conditions of like it always the spec and the status are two things that in Kubernetes you are like following. But what type about designing that API in terms of we getting into Kubernetes domain like CRDs that you mentioned about APIs, like you mentioned like any API that you can change, you own. Anything that you don't see, the platform team owns. But there's some gray lines around that aspect, right? So for example, if you put if they create a database and there's like the backup mechanism or the maintenance window, the developer team may not have the idea what to put in those fields, right? But they're available to be configured or the state to be that spec. So maybe that spec is shared, or maybe sometimes it's always defaulted, or is it like if the resource is being created in a certain namespace or Kubernetes cluster like production, there's certain like values that are like required, versus if they're created in staging, then like you can use a database that is less memory and less CPU, right? But if it's in production, it needs to be higher than X. Like those are great areas when you're designing APIs. What are your thoughts around like your experience so far of defining those APIs, defaults, putting defaults based on the environment that is created, or hide those APIs? Like what's your thoughts around? Because a lot of people had a lot of questions when they start, like they get the project, right? They can use ACK, they can use curl, they can create a Kubernetes controller. I think the most difficult part is designing APIs, because APIs should not change in theory, right?
Yeah. So one thing I'll plug, I have a lot of thoughts, but like a great source of information for that is a link that we'll share at the end about Brian Grant's blog on declarative infrastructure as code. He's a very early engineer, lead architect for Kubernetes, who did a lot of work on designing this system. And if you scroll through, there's some good articles about why it's designed a certain way and some of the benefits of doing things in this manner. So there's some great points about like, how we made the flat file configuration the same as the API format and why that's beneficial, but also what some of the drawbacks are. So I would encourage folks to read through here. I'll give you my thoughts, but that's another great source with a pretty extensive set of information on this.
Yeah, and they're very recent. Like you can see for everybody, like I started like I think end of last year, started like popping up in my LinkedIn, right? Maybe LinkedIn already knows that this type of stuff that I read, where I spend more time like scrolling. But it started like popping up. Brian's blog post started popping up in LinkedIn recent. When I say recently, like in the last 6 months, he's been like putting a lot of ideas in blog posts around like defining these configuration infrastructure. At the end of the day, it's infrastructure as code. Because you're defining or data, like other folks saying like infrastructure as data, infrastructure as code. Basically, it is configuration. But one of the tenants you mentioned something around GitOps.
Yeah, exactly. And GitOps, and that really kind of goes hand in hand with the idea of like declarative configuration, and essentially the fact that resource management is generally best done in this declarative manner. And that has a great fit for managing its flat files in Git. And it also makes some of the responsibility more clear. Like I talked before about how sometimes an anti-pattern is I'll be the pipeline engine, just use my pipeline engine with whatever automation. But there's actually this fundamental difference between, okay, but is the automation is that client side or is it server side, right? No, and if you get, another way to think about it is, does the application team need to trigger the automation, or should the platform team trigger the automation? And so you think
Interesting.
about this case of like a database or like or Kubernetes cluster is a great one. There's a lot of benefits to having the platform team responsible for running a lot of that automation. Maybe a node starts failing. Well, if it's declarative, the platform team can respond to that event and handle it without even needing to involve the development team. They can go spin up new replicas of the application. But if the only way to spin up a new instance of your application is via some pipeline that the application team owns, the platform team can no longer respond to those types of events. They have to pull in that application team. So it's a fundamental premise here of like a lot of resource management. There are benefits to putting things on the server side. There are also drawbacks, though. It's more expensive, it's more complex, and sometimes a lot more difficult. So that's the trade-off here, and it impacts that ownership, right? Because it means what the platform team can ultimately do.
Yeah, and it follows. And if you have a shop, I mean, it depends the tool, the choice, right? But if you have a shop that you're already like using declarative configuration, I won't say infrastructure, declarative configuration for hundreds of applications, right? Like there's companies that have hundreds of applications running on Kubernetes. They have like that already background and knowledge on how to configure that configuration, how to package it, how to link into it. Then it's a matter of translating or taking those learnings about declarative configuration to declarative configuration instead of a pod or a deployment or a namespace or a network policy to like dependencies, right? An AIM role, an AIM policy, and a storage bucket or a Kubernetes cluster, right? You need to create Kubernetes clusters, then declare on configuration how those clusters should look like, right? You're going to start a project. Maybe you give that golden path or like that scaffolding to the application team, like you shall need like 3 clusters, for example, one prod, one pre-prod, and then one staging, and each one will have a different configuration settings, right? But you're going to deploy the application and promote it. That orchestration and that infrastructure, if you don't have a central team or a platform team that have done it before, it's going to be a lot of work just doing imperative, right? Through pipelines, like running a pipeline to just create that thing again. And if it's different, you have to run the pipeline again, start from the beginning.
Yep, exactly. Yeah, it's so hard to recover from failures. That's a great point too. Like, because those pipelines assume ordering, but just to kind of reemphasize what you're getting at is most application teams also they don't want to be thinking in terms of infrastructure, right? They want to think. You think most or like a modern like cloud SaaS application, you probably want to think in terms of I have a back end application, I have a front end application, I need some resources like a database. Run it, just run it for me. I don't care how, and they don't need to be thinking most of the time in terms of like I want a kube cluster and I want it on this type of node and I want this type of database. So what's really neat in this whole pattern of using Kubernetes as a control plane is that Kubernetes is a fairly low level set of interfaces. When you're talking about pods and deployments and services, those are infrastructure concepts in a lot of ways.
Yep.
And so Kubernetes itself is a pretty low level interface, but now it has the framework to build these higher level interfaces via series. And so we can get there. That's the hope. It's like you can get there where engineers are thinking in those higher level concepts.
And for your team, when end users have applications, right? They might not worry about if it's running on premises or on cloud. Like you have that flexibility of like they work on writing the business logic. They follow best practices to create the Docker container or Docker file, right? They use like lean small images like ChainGuard or like small images. And that stops. Like it's the platform team. Give me a Kubernetes cluster. It could be on premise or it could be already running on premise, and you're transitioning that app to the cloud, right? Migrations to the cloud, and you just need Kubernetes on the cloud, and then the app just deploy it in 2 places and start moving traffic, moving data, right? That data needs to be close to the application.
Absolutely, yeah. And so interesting thing we've looked at pretty extensively, and we've got a fair amount of software using is OAM for that exactly that use case. Because one of the problems you run into there is like it's great you can make those high level interfaces and start to remove the infrastructure from the application in its configuration. However, you then come to this issues where, okay, but I also need some way to do sort of like variations of those dependencies depending on the environment. Maybe in an on-prem, I'm going to run a Postgres managed within Kubernetes, but maybe in a cloud provider, I'm going to use their managed database instance. And they're going to be a little bit different and to be configured a little bit differently. So there's this whole, you need some way to take your application and infrastructure configuration and come up with some variations on them, but also keep them bundled and understand those dependencies.
At OAM, this is what you're referring to, the open application model?
Yep, yeah, and I'm honestly really, I think this is an area that there's a lot of room for improvement in the Kubernetes space. And I'm convinced, it's been surprising to me how late this idea of application modeling has started to show up here. I didn't know the OAM and folks have, I think, got there earlier than most other folks, but there's a lot of room for improvement here. There's so much more we could be doing.
Yeah, and it is, and people have created all the open source project, right, to create variations of this. But yeah, this is, for example, Kubevera is one of the implementation of this, and the same concept applies to other projects like Crow. We're the Crow project, the KRO project that we're doing with Google, Amazon, and AWS is the same similar thing of creating definitions that you can put together: the compute, the storage, a dependency, a database, as dependencies, right? You have an app, and the app depends on other things, right?
Yep.
And if you can compose the definition, the declarative, and then put that in Git, then it's a matter of GitOps, right? Using Argo CD or Flux to say sync this configuration to etcd. I usually say that on purpose because a lot of people think that Argo CD is like and Flux are a magic thing that deploys your application. It only syncs to etcd, right?
Yep.
And then you have controllers that take over these models, right? That live as CRDs and they convert them into actual instances objects. So let's close out with GitOps. Like, what is your thought about GitOps or the interface, at least middle ground on like providing a interface that is you said that you have 10,000 of developers. Most likely they're using Git or source version control. I used to have SVN and I use all of them in IBM.
Yep.
But I think Git is kind of like a place where people like I treat it in as like there's a folder that's my name or my team, and I put like files, configuration files in it, and then GitOps takes over it.
Yeah, and in Siemens, I can tell you, we have every source control system under the sun. Like anything you can think of, we have it. It's interesting. We've just been doing a fairly large analysis of it because, sort of to your point, it's very clear that Git's the standard. Like that's what we need to standardize on. And there's a lot of benefits. That source control system, when we talked very early on about how there's compounding effects of standardizing certain things. Source control system is definitely one of them. You think about like, okay, enabling teams to collaborate with one another. If they're using different source control systems, that can be a massive barrier, including things like, not to mention discoverability, and then all the tooling you need to build on top of it. So yeah, well, one thing we know is we have to standardize on a Git-based technology across the company. Like I said, we are using it a lot already, but there's also every other system you could possibly think of.
So that's the desired state, where the desired state lives for both apps and infrastructure.
Yep, absolutely. And the other benefit, the reason that standardization is critical, and I've seen with other companies that have less diverse source control tooling, is that creating, it's a thing called like concept minimization. But even if there are slightly better ways to do something, a lot of times, and especially in the source control in AAC case, I found this to be very true. Having only one thing that your users have to learn about, even if it's not the best thing, is often better than having 5 things, right? And so, look, everything is going to be in Git. And we're going to have standard processes for approving changes, auditing changes, reviewing changes. It really minimizes the concepts, and people can start to apply them in a lot of different phases of the SDLC, rather than just saying like, oh, I'm not knowledgeable. A developer can go there and say, I'm already familiar with this thing. Great, I know how to be effective here. I know how to communicate. I know how to collaborate. So that's another reason why this GitOps thing, in addition to all these declarative benefits we talked about, I find GitOps to be a very attractive option for a lot of different capabilities.
Right. I'm showing here one of the projects that Siemens is part of, the Canoe project, and it has some resources around creating a platform or a stack of an IDP, right? But it's focused on GitOps. This instance today is Argo CD, and we're looking if people want to contribute Flux into it. But the idea is that you're using Kubernetes. It's an automation to set up all these, like deploying with Argo CD all these add-ons of like Keycloak and Argo CD and Argo workflows, and optionally a backstage where like everything is centralized around GitOps to deploy the applications and deploy the resources associated that depend on that application. So if somebody's looking for like blog posts, best practices around GitOps, using APIs, Canoe is a project that the learnings from these companies like Siemens, Adobe, Autodesk, Twilio, Salesforce, all these people have like large corporations like Siemens that are building a centralized platform, but it's a centralized platform that is developed, like you said, with empathy with the users, going to the users first to get adoption. Like how is the work they work? If they put all the configuration in Git, then it's a matter of like helping like bootstrap new projects or take existing projects and taking them into a way that they just declarative put them in Git. And then these systems, these controllers that run Kubernetes with the programming model of Kubernetes deploys the applications and the infrastructure. And then it's a matter of like ownership, like who owns the API, who owns the CRDs, who puts in place the guardrails with validation policies. Now that Kubernetes has a mission controllers, there's more richness that you can do with CEL, and things like Kyverno and Open Gatekeeper that always are in place. So I don't know if you want to give some closing thoughts around Canoe, and then I think that's an episode. We cover a lot of things, Greg, today. Thank you for having coming today.
Yeah, thanks for having me, and thanks for bringing up Canoe as well. You and I both have been heavily involved there, and what's been really interesting to me is it's all these member companies sharing how they work in this space already internally. And I know what's happened is they shared, okay, your developer platform roughly looks like this, this other company looks like this. Oh, it turns out, a large portion of this, we're all just doing the same thing.
Same thing.
It's already standardized. There's a de facto standard in this space. We just need to write it down, and then other people can learn from that. Because if you're a new company, like look at Siemens, we're pretty early on in this journey to build up this large scale developer platform. It's scary. It's like what okay, I've heard that Kubernetes is standard technology, but is it really standard used as a control plane? What about the GitOps engine? You're talking about like, Argo and Flux. What is the actual standard there? And there's not great information out there. There's a lot of different stuff about like, hey, this technology can do this. There's not great adoption information and implementation information. And this was a very valuable resource for getting that. Answering what is actually in use at scale at these large enterprises.
Yeah, building confidence, right? On like other companies, like not sure if like is this work at scale with a large number of developers, does it work at scale with a large number of compute resources or IT resources around the globally, right? Are people using it in secure environments? Intuit is financial, right? Adobe is creative arts that has IP. Autodesk has IP, right? These are like sensitive systems that we're betting that need to be secure. So so scaling means a lot of things, right? Not just like they have horsepower, but it's like scaling in terms of like these projects are open source, are they well maintained, they have the good license, can they be secured and locked down, do they have communities around it that they're going to be around, or there are welcoming communities that are welcoming PRs and community events. So most of the companies have given talks in KubeCon and the co-located events. So they are like part of the community, not just like users of the CNCF landscape.
Yeah, that's a great point. Yeah, maybe a better term than scalability is probably like enterprise readiness. But
yeah,
you're totally
enterprise
right.
readiness. operational excellence, that
Mhm.
canoe acronym. uh, right. So with that, I think, Greg, we had a great episode. Thank you so much for sharing the lessons learned from Siemens, which is a organization that have been around for many years, and all, like, everywhere. Like, Siemens is everywhere. They have a large amount of engineering workforce, and I think you're lucky to have that problem of, like, solving one of the biggest platform in the world with Siemens, using infrastructure as code, declarative APIs, and modern technologies using open source. So thank you so much for being part of the community and sharing today your knowledge.
Yeah, thanks, Carlos. It was wonderful being here. I love talking about this topic. So thank you for having me.
Okay. Thank you so much, folks. Subscribe if you're watching to the YouTube channel, or follow the page in LinkedIn. And we'll see you in the next episode in the platformers. Bye, folks.
Yep.